report because both the destination and the source are covered. Okay, so yes, we do want edges. So yeah, I think we want edges. I don't think we can complain about that. So let's go and implement it. Let's do it. So I think I might do a per core bitmap. The per core bitmap will have per core bitmap. Would it have better performance properties? Not really, because it converges to you only doing reads of the bitmap. So I probably want to do a shared one. So yeah, we'll do that. So we'll have the corpus here, and then I think we'll just throw it in here. We'll have a coverage bitmap. Pub coverage bitmap, and this is a vector of U64s. And this one will technically access with other threads mutably. We'll break some rules, but it's for perf. Coverage bitmap. So we want the coverage bitmap to be relatively large. Coverage bitmap is a vec0 for. So this is this allows 64 million bits, right? Because it's 64. These are U64s. So this is 64 million different coverage events or things. The odds of a collision are very low. I'm okay with some level of collisions. Does it ever get faster than F and V and still be reasonably hash collision resistant? What's F and V? I'm not familiar. So 64. There's 64 million different things, and it only costs 8 megs of storage. It's not expensive to store that. In fact, we can just do something larger, and we can say like 16. This is now 16 times 8. This is 128 megs, which is 128 times 1024, 1024 times 8. This is 1 billion bits. So we can do a pretty wide fucking hash and get away with it. Right? Honestly, 1 meg's probably fine. But then we will go into the code and on branches. And branches will happen where? We have jump and link. And jump and link has a fixed target. So for this, we can say, now we want to generate some code. Why bitmap for coverage tracking? It's just kind of the best data structure for coverage tracking because we can use it to store arbitrary things. We can, all we have to do is hash something and throw it in the coverage bitmap, and we can create coverage for anything. If we wanted to create a coverage event when we load a PC value with this instruction of 3187, all we have to do is create a hashable event for that situation, throw it in a bitmap. If we were the first one to set the bit in the bitmap, return out with the coverage event, and then we dedupe on the other side. But it means that it's agnostic to what's being stored in it. We can just literally have anything that we can hash can be coverage. That could be a memory access, a unique register state being observed, a unique state variable being set in a class and some data structure that you instrumented. Like, that's why I love stuff like this, right? For example, if you were fuzzing like Firefox and there was a state machine like set state enum, you could put a breakpoint on that, or you could modify the JIT to explicitly generate code that would maybe set a bit in a bitmap or change the state of things. So, Nightshade, dude. See you around. Yeah, it's gonna be like 2 days of uploading to YouTube at this point. F and V is this? What's this? I've never seen this before. So it retries? XOR folding, yeah. Non-cryptographic. How cheap is this shit? For each byte of data to be hash multiplied by some prime, and then XOR with the byte of data. That's pretty close to, I think, what I'm going to do. Rusty is or was using this. Huh. Very simple to implement. Multiply hash by the prime. So I could just, I think that's roughly what I'm going to do. So what I effectively will do, I typically XOR, but I could do the same thing where I just take, oh, I see, that's multiplying the hash. Okay, well, anyways, now we're going to bink, 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 bink. Okay. So we want to, we have the target, constant. We have the current location, constant. So auto hash is equal to Python import random hex random dot rand int 0 2 to the 64. Okay, we got two good random numbers here. So auto hash is equal to, this is going to be the target XORed with this, and then we'll we probably want to do like a shift here. I might do one round of XOR shift on this. And then we'll XOR this with this new one. Okay. So we take the target and XOR it with this. We take the dest and we XOR it with this. That gives us a hash. Now, I want to add some shuffling to that value. And to do that, I will do hash XOR equals hash shift 13 17 43. This is XOR shift. So basically, shuffling some random shit into this, shuffling some random shit into this, XOR them together. And then 1743. This makes sure some of the bits kind of end up everywhere. And this should be pretty good. And it's basically free because everything here is an XOR or a shift. We have a load immediate, Well, these will get const propped. Yeah, this will get const propped. For all branches, this will just get const propped because this is a constant, this is a constant, and it'll just compute this shit. Like, this will get generated at compile time, at build time. It'll make a single hash. So, missing an L on the second constant, thank you. Does that make sense? Because this is constant and this is constant. So the first one is PC.0, the current instruction. And then the target is the other one. So we have the PC and the target. And we just do this like little shitty hash. And then hash and equals and equals, this is the coverage bitmap length. Corpus.coverage bitmap as slice. Oh, we can just do this. Size of val. Coverage bitmap as slice. That's the size in bytes. Multiply it by 8. So get the size of this in bytes. And then multiply it by 8. Oh, here we can do this. Assert. Let's do let coverage bitmap len is equal to this, or bits. Coverage bitmap bits is equal to this. Assert coverage bitmap bits dot count ones is 1. Coverage bitmap number of bits must be a power of 2. Right. Coverage bitmap must be a power of 2. And then we can take, since we know 1 bit is set, we can do coverage bitmap bits minus 1 and equals that. Right? So now that has masked it. So now we have a bit index into there. And then we'll want access to the coverage bitmap. Okay, coverage bitmap. Tracelen, cov bitmap is corpus coverage bitmap as pointer as usize. So now we have a coverage bitmap, and then this is a const uint64t. Can't say restrict on this one. This is a pointer to the pointer doesn't change. The pointer is constant. Yeah, the pointer is constant, but the values that it's pointing to are not exclusive. And this is the cov bitmap. Okay. Then we will take state cov bitmap auto index is equal to hash mod div64. Auto bit is hash mod 64. Coverage bitmap, and this we can do 1 ULL this time. Shift by that, that's the bit, and then we can say if state coverage bitmap index and bit is equal to 0. If the bit is not set, then set the bit or equals bits. And then we want to do a return. I'm going to do this. And we want to generate a coverage event. State reenter PC is xull return. And so we have the bits -1, and then we pass in the current PC. Current PC, XOR the target, do this shitty hash, and this, compute the bits. Once again, all of this stuff will get const propped for almost every single branch. To be honest, I can mod equals this and then get rid of the -1, so it's less confusing, but I don't know. If the bit is 0, then set the bit, set exit reason for coverage, set a reentry PC to here, and set return. And then I think I just want some extra fields here where it's cov from, cov to, and then we'll just have these fields as well. We'll just throw these in here. U int 64t cov from, U int 64t cov to. Okay. And then we can say state cov from is ull, cov to is this. So then we'll have pc.0 from target to, and then pc.0 is the reentry point. Set coverage. Okay. And almost all of these are going to be constants. For all branches which are not indirect, everything here is a constant. This is just a constant offset. This is a constant bit. These are all constants. Like, this gets really cheap. It looks expensive, but it's not that bad. Okay. Guest state cov from, cov to. I doubt this will be like a 5% slowdown. Size of val. Okay. 71. Ah, yes. Coverage. Coverage. 1168. Coverage. Okay. New coverage. X. Self state dot cov from, self dot state dot cov to. Okay. And here we go. Yeah, new coverage from here to there. So if we do this, this 66B34. Yep, that does a jump in link to 1129C0, right? So now that gets plumbed up to us, and then it gets muted. There's race conditions here because we're not atomically setting it, but that's fine. because they'll just report them, right? Eventually, they'll stop reporting it. This is something that I do with all my coverage mechanisms. I don't actually use atomics, because if something ends up discarding a coverage result, it doesn't matter because someone's already reporting it, if that makes sense, right? There's no situation where a coverage event can get trampled without someone reporting it anyways, and if multiple cores report the same coverage, that's fine, we dedupe it. This is a filtering mechanism to reduce the amount of times. This is just a filtering mechanism to reduce the frequency that we invoke the coverage exit. Will every Fuzz Week stream be uploaded to YouTube? Yes. Auto hash this. It's like how you're doing in analytic systems. You can often get away with something like MongoDB, where you don't need full consistency because you don't care if some hits get discarded when you just care if anything got hit, so to speak. Yep. So I'm thinking about putting this into a macro so that I can expand this a little bit better. Because this is like coverage event or something. From to and then this and this we'll use some labels for this. This is a bitmap, hash mask. This is from. This is to. It's from. In fact, that one can just be hard-coded PC. We have to put this inside the scope if we're using PC. Okay. PC. From is not always going to be PC. I'm not going to make that mandatory. PC is equal to PC.0. From is equal to from. 2 is equal to 2. Hash mask is equal to coverage bitmap bits minus 1. Right? So, from and to. From and to. Then we generate the hash. Then we AND it with the hash mask, which is coverage bitmap bits minus 1. We then we find the index in the bits. We call, if it's 0, if no one has set this bit yet, then we set the bit. And that could potentially clear someone else's bit, but it doesn't matter. Right? Let's imagine that this reads the wrong value and OR's in the wrong thing and clears someone's bit. Well, if someone was just setting a bit, then they were in here anyways, and it doesn't matter because we already captured the event. Exit reason is coverage. Here we're going to give the from. Here we're going to give the to. And then the PC is actually the PC. So from and to could be arbitrary. You can make up your from and to. Okay. So then, now I want to do on a jump and link. Unconditional branch Otherwise, it's an indirect branch. So here I can say coverage event format, because I have to, ULL of the PC.0. And then this is target. So this should work. Yes. So we're getting coverage events, right? We get that first coverage event. Looks fantastic. So record coverage. And then we can disable coverage in one handy dandy spot. So jump and link register. This is an indirect branch. And that is loading the target into target, literally called target. And in this case, target is actually a variable. So we can say, take the current PC, and then take the target, and that's what I want you to use. So now you record coverage for that. Now, for branches, do I care about fall-throughs? If I care about fall-throughs, I might need to add an else statement. So this is in the, this is if it's going to the target. And we call it target, right? Yeah, jump to target. So record coverage for true condition. And then that's a go-to. And then in the fall-through, right, for the false condition, the target is the next instruction. Cue exploration of that. PC.0.wrapping add 4, right? So we're branching from there to there. And I don't think there are any other branches. Unconditional branch, covered. This branch, true condition, PC jumps to target. So the current branch instruction jumps to a target. And then this situation, if, then go to this. Then in this case, this is the false condition, and we're just going to the next instruction, right? We're at this, and we're going to the next. And then I don't think there are any other go-tos. And now that's only on branches, and this should be pretty cheap because all those things are constants, right? These are constants, and these are constants, so the hash is then a constant. So now we have coverage events for something like this. Is this what is this? This is a branch if equal to 0. It is branching to C18. And let's try and find one that's just falling through. See if we can find one quick. I just want to make sure all of them are working. I'm going to have to let this run a bit. Okay, did we do something wrong? PC, go to inst in that if. Have we just not had any fall-throughs yet? 112.780. That's jumping to 112.7 AC. Like, I am very confused why I wouldn't see this. So, 1 through on DBO. Branch if less than 0. DB0. And this goes to, oh, that goes to DB4. Yeah, that works. 1 through on DB0 goes to 131 DB4. And we'll also get coverage on unconditional branches. We'll get coverage on every branch. The current PC to the target, regardless. So, yeah, that was one. That was a fall through. We went from DB0 and we went to DB4. So I do think this works. Oh, here we go. Here's a loop. 115C1C. We see it branching to COC, which then is a loop. This is memcopy. You go back up to COC, and then eventually we see new coverage when the C1C ends up branching to C20. And then we see C20, which is the return, jumping to 2CB18, which is returning back to after memcopy. So that's an indirect. We've seen the direct call. Here's the call from C14 to B94. So that's looking pretty clean. And I highly doubt there's really a performance hit to this. So, new coverage, and then coverage, how do I currently store it? Code coverage. This is, code coverage is to and from edges for all branches, including fall-throughs and conditionals. Including fall-throughs, conditional, taken, not taken, indirect, and unconditional, right? We don't care. It's every single branch. There's just not enough cost to justify not storing everything. And then we can store the vert adders in here. And then code coverage, entry or insert. This is an emulator. We're gonna turn this off temporarily because we're not doing it this way. And we have nowhere else doing code coverage, which is great. Coverage, new coverage here. Update code coverage. Dink dink, dink dink dink. Push. Okay, so let key is vert adder PC as usize. Vert adder, oh, this is, we'll just do this. Vert adder self.state.from cov from. And then we have cov2. And there's our tuple. And then our hash will just be and those are already U sizes, I think. No, they're not. They're U64s. As U64 or U size, I don't really care if there are collisions, right? Because the collisions will be handled based on this. So I don't really mind if this has collisions, which it will because it's not including the from part. It's fine because everything's ends up checking on this, so it will slide through to the next entries. So this table will not have collision problems. Even if there is a collision, we still get a unique entry based on each key that we store. Then, if we inserted something new, hash the fuzz input, and then, if it's a new unique input, save it to the input database. Right? And then, code coverage will just continue through. Okay, and then fall through to re-execute instruction. And as long as that coverage is done, we need to make sure no side effects occur. No side effects can occur because we re-enter the instruction, right? So we have to make sure that all the side effects happen after this coverage. So in this case, that's not a side effect, it's a temporary. Because when we're done with the coverage event, we're going to enter back into the same instruction and re-execute it. Technically, we could have it jump to the target. Yeah, if we just actually have this, set the re-entry point to the 2 location. Yeah, but then 2 actually has to have that meaning, but I think that's acceptable. So we're going to say 2, it's required that 2 actually is where you want to go to. So coverage from, coverage to, re-enter PC. And now it doesn't matter, but we still preferably do it before any side effects. So this is set the return address. Then here, no side effects yet. Set the return address. And then here, no side effects. Nope. This is a side effect. Yeah, no side effects. And it doesn't matter because we'll actually end up returning execution to the branch location. Okay. Segmentation fault. Okay, not a good sign. Crashes, unique cases. Yeah, are we re-entering to a fucked location? Yes, because it didn't execute this instruction because it's prior. Because this is prior. Yeah. PC is PC.0. We have to do this. Because since the side effects haven't happened, ULL. We need to make sure that we re-execute the instruction because the side effects of the instruction haven't occurred. PC. The side effects of the instruction haven't occurred until we re-enter, because we haven't set, like, return addresses and stuff. Still shouldn't cause a seg fault, I don't think. Maybe it would. But we re-enter, we re-execute the instruction. So I will say, notify, attempt to notify of a coverage edge from 2. Note, this instruction, or this will cause the current instruction to be re-executed if the coverage is new. Thus, it is critical that no side effects occur prior to, it's critical that no side effects occur prior to the coverage event macro use. Where do you get the PC from in the macro? Yeah, it's from here. That's why we had to declare it in this scope and not here, so it could get the PC from this location. But it looks like we're getting coverage events. We have edges. Okay, and we have cache stuff running. Here we go. Let's run it. And we should be getting perf here. 108, 123, 133. What were we getting before for performance? Like 230? I think it's still climbing because it's still compiling a lot of stuff. I'm actually surprised that it's that much of a hit, to be honest. Climbing. All cores are up. Because I think we were getting 230,000. Is it really costing us that much? I kind of expected it to be a lot cheaper. You do at least one memory access for every jump, yes. So we were getting 230, we're at 170. A 35% slowdown. I could get rid of it for unconditional branches, but I don't think unconditional branches are too common. Yeah, let's drop it for unconditional branches, maybe. Because unconditional branches, it doesn't really matter on. And that's like a decent amount of stuff. Coverage events. This one we have to do, and this is the expensive one because this is dynamic. And these should be relatively cheap. Okay, I'm going to disable coverage events for everything except for indirect branches, and we're gonna see how much perf we lose or gain. And this will give me a good idea of if I'm losing my perf. Like, if I'm not really paying a cost for these, right? If these aren't really costing me anything, then I don't want to optimize them. Because this is the only one that's actually expensive, because this one has to do a dynamic calculation. And I think jump and links are relatively common. So, indirect branches include all rets. Yep. So there's a good chance that we're getting the other ones for nearly free, or there's a good chance that these other branches are really fucking common, and it's hurting us quite a bit. We could also try a shittier hash. How many 5-hour energies do you need to stream for 19 hours? I mean, it's pretty easy, I think. Not too bad. Conditional branches will be your loops, right? Yeah. This is looking pretty solid, to be honest. This is, I mean, it's still a decent slowdown. 230 by 195. Why do you use Debian? I just prefer it. It's more stable. Works well. Third-party things work really well on it. 230 divided by 198. Maybe my hash is too strong. Maybe my... Maybe this is just a bit much. I only have like 5,000 unique things or something in coverage. Let's say 10. Let's give it 50,000. Enough room for a decent amount of collisions. Or 64 times 1,024 divided by 64. 1024 on this. Yeah, I could drop this down pretty dramatically. We'll go to 16 times 1024. 16, 1024 times 64. This is 1,000,000 bits. And it's 131K. To be honest, this is probably fine. 1024 times 64. We'll definitely have collisions with that. What's some square root of, or we're getting like 5,000 squared. Yeah, we actually want a bit more than this. We'll go to this. This might help a lot. This just increases a lot more cache locality, so I'm not missing cache every single time. If it's not an improvement, I'm not going to keep it. I'll go to a larger hash table with a lower collision chance. Okay, we should be able to see decent numbers now. Doesn't seem like that made a major difference. If it was just a full random number for block 1, a full random number for block 2, and XOR it and turn it into an edge, yeah, I think so. Something like that. Okay, well that wasn't a huge speed up, so let's just go back to the large table with low collision chance. Put everything back on, and yeah, it was like a 30% slowdown, which honestly isn't terrible. We could try and cut down on our reset times a little bit. Let's go to a larger block size. Let's go to 512. We had 5% resets before, and we'll see what this does. Okay. No fuzz cases done yet. Wow. Okay. Otherwise, we can drop down to a lower block size. Kind of depends on how sparse the axes are in here. Okay. Looks like it's nearly done. We probably can get decent numbers now. 3%. Okay, that looks like that helped caching, or the reset. Yeah, we've got more time in the VM now. 166,000. It's pretty solid. Wait. Am I dumb? I could... I can... I can use a static. I can use a static here. I could do like static cov scene is static int cov scene is false if not cov scene. This will break for indirects, but let's just try it. Zero. If coverage not seen, coverage seen is 1. That's gonna go in the data section. Oh, percent or parens. So basically, only report it once, and then we bypass all this expensive lookup, and we're just grabbing something like relative to the data section, or like close to nearby to code. So this segmentation fault. Did I run out of cache space or something? Why would this crash? Are you actually loading the data segments? Yeah, I should be. Is the data section ending up before code? Text note BSS. Oh, is it the BSS fucking me? But why would that matter? Why would that matter? Is it pick? It should be. But like, why would I be executing the wrong things? Oh, the BSS isn't counted as a section. Since the BSS isn't counted as a section, this is writing over. The BSS is not included in the output, which means that it's basically writing over a variable out of bounds. So, can I like linker script BSS? There's got to be a way I can like force the BSS to exist. Otherwise, I can set the variable to 1, which is kludgy. BSS is that. Define BSS right after data in the linker script. Okay, I think what we could do is, can we just do this? Now it's not BSS, right? Yeah, you're picking up what I'm putting down. If it is seen, and then we can rename it to something more meaningful. But this shouldn't crash now, right? Right? This shouldn't crash. Should be pretty cheap, I think. Yeah, it's not going to crash now because it's not BSS. Fuck. Is there still BSS? Yeah, there is. That's some bullshit. That's some real bullshit. It's 0 before the first function run? I don't think it would be. That wouldn't make sense. They're initialized on the first call to the function? How is that done, though? How do they know it's the first call to a function? Inserts code to do it. Gross. I'll give that a gross out of 10. Force. Yup. Change it again. This is saying it should be in data. I have no idea. Like, I mean, arguably, maybe I'm looking at an old file. So, let's put it back in, run it, and see. But that's potentially what's happening here. Yeah, there's BSS. Cub scene. Yeah, it's in BSS. What the fuck? How do you have multiple functions in the same compile unit? What do you mean? They're different scopes. Isn't there from the file? Yep. Define BSS right after data in the linker script and update the location counter using size of. Something like BSS followed by this. That's some gnarly shit. How do we obj copy this? Oh yeah, and we have some fucking notes in here, don't we? Remove property. So if I do a arg copy O binary, remove this, foo. This is gnarly alignment. Okay, so let's try and find something that's doing a riprel. Or that. Move byte 1. Here we go. 8d8. Vim dash 8d8. Compare with 0. If it's non-zero, go to 3f. And just skip all this shit. Otherwise, store this. And then 8d8 is not... No, it's in here. 8d... That's in bounds. That's in there. Huh. I have no idea. Well, I think that's something to figure out another time. What's going on here? What did I break? 1354. Oh, yep, thanks. JIT cache star. And then let's try even larger of a block size. The downside of coverage is it does cause re-entry into a PC, which will cause me to, it'll cause me to have to relift the function in the middle, but that's kind of okay. Might yield like a lot more code getting compiled than I need to, because I have a coverage event that causes me to exit, and then I re-enter at the PC. That PC is not in the database, and then I have to relift the function from that point. But it only actually, it doesn't really affect performance. It just increases bloat, because, yeah, very quickly that just won't be an issue. Okay. Okay, that's looking good. So I should be able to do fuzz results, gnuplot plot.plot, or make. This will give me the plot of coverage, and then I'll just remove stats, baseline, stats, no code coverage. And then this will be my, this has coverage, but it has no feedback. So we can see roughly how this compares to having and not having feedback. So we're going to enable feedback in a second here. And first, I just want to see if this perf is looking good. Yeah, this perf's looking pretty solid. Make. Oh yeah, and this x-axis is in fuzz cases, so the time it spends to JIT things won't affect the shape of the graph, if that makes sense. Since time is not in here, it's only fuzz cases, so if something goes and JITs for an hour, it doesn't matter because the fuzz cases isn't advancing. So it makes these graphs a lot more readable. Okay, so this is without coverage, and without feedback. Looks pretty good. We are getting some boops up in here. But we get to show how big of a difference. So this is, okay, so we can copy, okay, that looks pretty stable. So we're going to copy stats.text to stats nocc.text. And now we have kind of a baseline that we've established with no coverage. And then what's our reset time? It's looking pretty good. Got 91% of the time in the VM. Fantastic. And we'll make another copy. Might as well. Now, we're going to kill it. And now we're going to add rng.rand. So now we're going to pick a random thing from the corpus and we're going to feed it back. So now we have code coverage feedback. So when new inputs are created, we'll log them. And we're going to get a shit ton more coverage because now we're doing feedback. Yeah, look at this shit. Look at what happens when you enable code coverage feedback. Fuck yeah. Fuck yeah. That's why you enable code coverage. That's looking good. We're going to lose perf. Perf's going to go down. That's just naturally kind of how it's going to go. Is you're going to lose performance. That looks good. Do you need to emulate a virtual network adapter in order to fuzz network-based application? No, you can just emulate like sockets, syscalls. Okay, so I'm losing a lot of CPU time somewhere, and I don't know where. So let's run this from scratch again. Okay, it was JIT stuff. Oh. I have no instruction count cutoffs. I have nothing here that will I have no timeout. So if I find an infinite loop, I'm gonna lose all my perf to that. Okay. So yeah, that graph looks nice. Okay. Let's get some Nessies going. So, now, oh yeah, there's a good Nessie right there. Yeah, bring it. Yeah, it's churning. We've gotten some good fix through here. Okay, stats to stats baseline dot text. And now we're going to kill it, and now we're going to update our corpus. We're going to make a better corpus, right? So now we have a couple lines. We have a baseline, and now we're going to improve our corpus, and I think you can do size. Yeah. So I can do find files which are less than 100K in user. Pass them to file. Find this, okay. Grep elf. Nice. So this is looking for elf files less than 100K on user. And then I can cut D colon. Fuck. Shit. D colon F1. Oh, pick the first thing. Xargs. I copy this to inputs. Huh? Look at that. I'm a bash master. So this is just going to grab all 100K files from my user directory that are elves, and it will whack them into my input folder. And now we get to see what a corpus does to your feedback. I don't think you're allowed to say bash master anymore. I wonder if this gets like stuck on some files. Come on, file. Do your thing. It's like it's stuck, but I don't know why. Like, why does it do this? Why does it get stuck? Still searching user? But how? It doesn't take that long to search a fucking file system. Ooh, we got some elves. Oh, they're coming in now. They're coming in hot. We found user bin or user lib. These are all 100K, so these are like relatively small inputs. Our perf's gonna drop a lot. 100K is a relatively large input. Okay, there it is. Watch. Yeah, I could do that. That would probably make sense. Okay, let's see what we get. Immediately, we're just compiling cache. Literally, everything's just fucking hitting cache. Or, missing caches. Compiling a bunch of shit. We're starting to see some cases getting through now. Yup. Starting to warm up. So this is what happens when you improve your corpus. That's what happens. No coverage. Coverage shitty corpus. Mediocre corpus with coverage. Right? It's just mandatory. Right? Once again, another reason why I don't really care about paper results because, these are the factors you're dealing with by having a better, shittier corpus. Like, spend an extra couple minutes to get a better corpus, and you get shit like this. Why is mint 0? We just don't have stat tracking yet in this. We don't have instruction count tracking. Now, we can actually probably, since that's restrict, we can actually do that pretty cheap. We can literally just count every instruction. Exect insters, usize, u64. This will just get propagated to returns, right? Returns will just update this. So uint64t exect inster guess state dot clone. I actually don't like that I'm cloning that state here. I want the regs, but that's it. So I'm going to make this, we're going to do this. Otherwise, we're including the fork stats, potentially, in our cases. So we're going to do, impl default for guest state. fn default yields a self. When you say it propagates to returns, you mean each branch will set some register with the statically determined correct value and only get stored in memory once at the end? That's what I would expect, right? Because it only has to be updated when you return because it's restrict. So it doesn't have to be updated to reflect for anyone else until the very end. So I would imagine it would just get propagated to the last one and it would just turn into the, like, value for that. I can't imagine this will cost anything to record. Okay. That's what my guess is. Who knows? Okay. State is this. State is state. Let mute state is guest state default. So we create a new state, and then we do state.regs is self.regs.clone. We'll just copy the regs. So we create a new state structure. We only copy the regs, and then all the other things stay 0. Which means we can update them when we feel like it. Okay. Now, self.state.insters exec is 0. What do we call it? Exec inster. Okay. Insters exact. And then insters exect. Oh my god, that just got fucked here. Okay. Insters exect, reset it to 0, and then we'll do We have no return path here. We cannot loop without resetting it to 0, so we can do insters exec is equal to plus equals self.state.insters exec update instructions executed from JIT state. Right, so we reset it to 0, we run shit forever, and then eventually we have to get to here and we update it, and then we'll go up and we'll reset it before we ever run code again. So that is fine there. 75. Fuck. Insters exec. Oops. Okay. Beautiful. Okay, so now we need to delete cache. I mean, it doesn't matter. We don't have to delete caches. But then all we're going to do is up here, program plus equals update instructions executed stats. And then we'll just do state insters exec plus equals 1. And that should be able to get optimized pretty fucking hard. Because it's just, we're updating something that is, it's restrict. This thing's restrict. I see no reason why it would actually increment this every instruction. It would just probably const prop it to the final one that updates it, and then update it at the end. Would be my suspect. What would be what I suspect. What texture is that? It's just Vim. Good old-fashioned Vim. Finally using block selection. Oh, you noticed that? You saw that? That was impressive. I actually didn't make a mistake there, and I was like actually painting in my head of not fucking that up. I was spooked. Okay. So now we should have instructions a second as a stat. Looks like we're getting nice and warmed up here. Should look like the same line. Yep. Nothing changed about execution. And yeah, it doesn't look like it really hurt performance at all. And I wouldn't expect it to. That would make no sense. Letting these caches warm up a little bit more. I'm gonna do O16x, O18x. Okay. Now it won't be jumping around as much on the screen. Okay, that's all cores online. That's pretty solid. We're getting about 76 billion instructions per second. And we just hit some new code. Has a crash been found during this stream? No. We're mainly just doing benchmarking. I'm trying to see what this is going to converge to, because that's really important to me right now. This looks pretty good. Code coverage looks solid. Things are pretty stable. We're spending most time in our VM, 91% VM time, which is fantastic. I'm going to let this climb a little bit, and then we're going to turn on permissions. I still don't have permission checks, so I'm not going to find any bugs right now. We still haven't disabled for perf. I'm going to call this 82K per second, and we're getting about 80K instructions a second. So 82 fuzz cases a second, 80 not 80,000, 80 billion. Okay, now we remove the cache and permissions. Now, comment that back in. Now we have permission checks. Okay. Yeah, 80 billion. Sometimes I forget. It's pretty good. Am I skipping to the first case? Or to the open? Yes, I am. Okay. Now we're just getting those initial caches pulled in here. It's fun watching things warm up more and more as they start not conflicting on the same cache entry that they're blocking on. Yeah, we're not really doing any cases yet. There's a doozy. I think they've gotten through the base ones, and now they're all hitting new coverage. Well, had something panic. Out of space and JIT. Okay. To be honest, we only had 16 megs. Honestly, wasn't that much. Wasn't that much in the JIT cache. What the fuck? Something exploded. Did it really just get that much larger with those permissions? I mean, I don't really give a fuck. I bet it's still gonna panic. I think something's exploding. Something's happening. Okay. 149. Is one of these just massive? Does something have like a big data section? Oh, no, we have exclusive access to the JIT. Okay. I bet one of these is just massive, and I am curious why. Did those just add up? In use. Whoa. Okay. Some of these are large. Setting duplicates, maybe a decent amount. Like, how does it keep growing so much? Are we just getting fucked over by some, like, large functions? I mean, some of these might be dupes. Let's dedupe it and try. Let's see what happens. And then a dedupe here. B-tree map from this to the U size. Standard collections, B-tree map. Okay, and this B-tree map new. Then okay. If let sum existing is equal to self dot. So first we look up if the address conflicts. Otherwise we look up if the address, update the JIT blocks, update the in use. Okay. Now what we're gonna do is if there is an existing self dot or JIT dot to dot get ref get code. If there is an existing one, else do this. New address is equal to this existing, and then new adder. Update the dedupe table, and here we can say so check if we already have identical code. We have identical code. Register this code also. Alias this code for the requested PC. Otherwise, add it. Do all this shit. And then jit.to.insert, and then here we assert, insert the code, and then new adder. And this will be .into is none, right? Up the dedupe table, take the code, clone it into a vector, and then record the address where to find it. And then here, we look up the code. If we already have matching code, then it's existing, and then we update the JIT lookup address for this new address, and then that allows us to bypass everything by doing a quick lookup from that point on. Okay. So this will now dedupe. I don't know if we're still going to have issues here. It's just not that many duplicates. Couldn't use the hash that was already used. Well, there could be code that could be identical. Isn't existing inside of the if let returning this? That's assigning to new address, which then I re-register. God damn. Like, are some of these just massive? None of these look crazy. I don't know how we're at... Wait, we're running at 16 megs. JIT cache. Why are we running out at 16 megs? Out of space in JIT. If JIT remain is greater than a line size. JIT 0 len. Oh, well, what the fuck is this shit? Oh, I see. I wasn't changing the size. This is the maximum virtual address to allow, which should be like 4 megs. That is for the lookup table, the conversion table. Okay. Hey, I mean, the dedupe might get us something. It's probably relatively pointless, but it's possible that the different code could result in the same JIT. Or actually, we register things in the cache based on the, yeah, there could be like duplicate thunks and stuff. There could definitely be situations where that would happen. Okay, 16 megs is reasonable. We're pretty hostile about making a bunch of dupes and stuff. Whenever we like re-enter the JIT, we'll end up JITting like a partial executed function. Okay, let's see what we're getting for perf now. So we were getting 82,000 a second, and now we're at 57,000 a second. 58,000 a second. We'll let this climb a bit. We don't really lose that much by having the permission checks, to be honest. It's like 82. Looks like this is going to climb to probably like 63. Yeah, it's like a 30% slowdown. Not that big of a deal. We have crashes now, which is great. Let's remove the crash files, and then here we go. This perf is pretty fucking solid. A 30% slowdown to add ASAN when ASAN itself is typically a 2x slowdown. Pretty fucking happy about that. Still running 50, 55 billion instructions a second. It's pretty fucking good. It's not Vecchimu, but it's good. I'd say this is pretty fast emulator. 2BH. Okay. Oh, that's nice. Got like an exponential on a log scale. Well, I guess that's more like linear then. Alright, let's get that crash. When doing hypervisor-based fuzzer, how do you record coverage? You instrument the binary. I'll typically do random sampling or processor trace, or I'll page things out randomly, or I'll single step, or I'll use performance counters. There's like a bunch of different ways, but I never really do binary instrumentation. I'm not too sold on binary instrumentation. It's a lot of work, and it's a very imperfect science. Yeah, it's looking solid. What's the benefits of hypervisor fuzzing? 0 bugs in terms of your implementation, so you don't have to worry about like implementing an instruction wrong and getting weird crashes because of that. And you get full performance. It'd be pretty much, it would be no more than probably 2x faster than this JIT. We're running at roughly the same speed AFL is, and AFL's running native. Yeah, I guess this is a little slow. I mean, this is also doing a lot more than you could ever do with a hypervisor. Like you can't do byte level granularity with a hypervisor like we're doing here. Obviously, you could build your targets with ASAN, but now you lost all your perf. But like we have ASAN with a 30% slowdown, which is pretty nuts. In fact, it's a little bit less. So we were getting 80 billion instructions. Now we're getting 57 or 58.7. And it looks pretty stable. Yeah, about a 30%, 36% slowdown here. Which is pretty fucking good. Will it be part of Fuzz Week? Will it be part of Fuzz Week? Honestly, the coverage gathering stuff was relatively expensive. Okay, coverage just keeps going up. Just one unique crash so far. Let's see. We have a null deref. That's probably an allocator failure. It's probably a non-checked null on a alloc. Malloc probably fails and then it gets really mad. That would be what I would expect. But yeah, we're not finding that other bug. We just don't have a good enough corpus for it. So what is this? Obj dump d object dump risc-v, L, vim dash, a null deref and a free. BFD hash table free. Kind of interesting. I don't think that one's going to repro. Nope. Okay, let's copy from user lib32 star to inputs. And let's see how much that changes our coverage by. Oh, and yeah, here we can take copy stats to stats large corp, larger corp.txt, make file, or plot, small corpus, large corp, large corpus, small corpus, larger corp, stats large corp dot text. Yeah, look at this. We just added a couple more files to our corpus, and we have much more coverage, right? An order of magnitude speed up in the time it takes for us to get coverage. We have more unique crashes now, too. Here we go. Here's a fun one. Exec. Segfault. Repros. Fucking easy. Fucking easy. Why is hacking so fucking easy? Yeah, jump to null. Okay, that's a fun one. What else we got? Oh, we got some more shit. A37, 168, exec normal, repros. Yep, jump to null. What else we got? 10B, read null. Okay, nope. 69C. I think we tried this one. Okay. Yeah, that's just kind of all over the place now, isn't it? 118, right normal? Yep. Yeah, it's not going to be happy now because we found arbitrary exec. Binutils fuzzing, get clone binutils gdb x86 to binutils gdb x86 asan. We'll stop this while we do this build. Configure. Yeah, this looks good. CC is, we'll use clang 10 f sanitize address undefined. Make J32. Can you try to get AFL to find the same crash? We can try. RMRF inputs, copy the inputs that we're using. Fuzz with emus. It should be able to find it. It's a pretty easy bug. Inputs to here. Okay. Well, these could be juicy. D, S. Let's just try it on 32 cores and see if it actually does anything. But my guess is this is not going to... Okay. Okay. So we should be able to look at outputs and then like one of the cores, and then we can look at plot data. Oh, it's not fuzzing yet because it's doing the initial pass of all the inputs, I think. And let's see. Is this building F sanitized address undefined? Nice. Hey, there we go. Nice, we're getting 1,000 execs per second a core. Not bad. Multiply that by 32 cores. So AFL's fuzzing my kernel right now. It's doing some good kernel stuff right now. That's pretty impressive. These stats haven't updated. I'm kind of confused. I think it might have gotten stuck. Yeah, I think it got stuck. Because it's doing some kernel activity. Oh, there we go. 2108 on that one. 1050 on that still. 2107 on that. No crashes yet. Yeah, it looks like... Yeah, no crashes yet. Yep. Okay. Well, we'll see. It'll work hard. I think I wrote a stat parser thing, didn't I? I wrote something called AFL bench, I think. Bench, AFL bench. AFL, okay. The fuck did I call it? AFL bench, one word. Okay, and then benchmark.py. Looks like it's getting decent perf. Let's try this. Git clone. Maximum threads, we'll use 32 for now, and then AFL 252B. AFL fuzz inputs, outputs, DS, thread ID, and then I want to run. Was I running this with the right args? Oh, I don't think I was running it with the right args. Where the fuck was I? So I want to do obj dump x86-64, and then we want the G flag. And I'm pretty sure we don't want to remove inputs. We will remove outputs. Won't make a test input. I think this should work. Build our test program, doesn't matter. Benchmark AFL. Spin up the threads. Did I spin them up one at a time? No, it makes all the threads. Okay. Python 3 benchmark.py. So I think this will spin up AFL and then give me stats. S implies D. Okay. Control C. Oh, kill all obj dump. Okay. Set no affinity. Yeah, so these were like the best results I was able to get out of AFL perf-wise. So hopefully this benchmark tool will work for this. Set affinity thread ID. Max threads. For all the threads, spin up threads. Wait a bit for the benchmark. Kill all the workers. Kill all fuzz bencher. Plot. Okay, so what do I fucking do here? Make fuzz workers. Wait for the benchmark. Okay. What's going on here? Print done. Okay, so that kills shit at the end. Go through this. For each of these, while true, do this. I just want to do benchmark AFL. We're just like hijacking this code, right? Max threads or something. Yeah. And then while true. Time sleep, I don't know, sleep like for 1 second or something. So start all the threads and then list index out of range. Okay, let's try it one thread for now, just to see. I just am trying to get the parser out of here, is mainly what I want. List index out of range, last status at 54. Content's -1. There isn't that yet. Try accept pass. Okay. Now we can spin up, let's say 32 threads, and then AFL will start running, and then yep, it's running stuff. Good. Okay, so this effectively, all this is gonna do is gonna parse all of the thread ID information and grab the total fuzz cases a second. All it does is it gets the last line in the file, the most recently reported total a second, sums them all up for all of the different threads that are running. That's it. That's all it does. That's the only reason I'm using this benchmark tool, because I already had that parsing, because AFL doesn't give you summarized stats between all the cores, because that would be ridiculous. Ah, son of a bitch. The fuck's going on here? Dev null. Dev null. Okay. I think I had that for like debug reasons or some shit. Okay, we have got object dump. Nice. Let's try this 118. Yeah. Yeah, PC's fucked. Leaks. Those ones don't repro. I think those are allocation failures. That wouldn't happen on this system. But yeah, it looks like it's just pretty much arbitrary PC. Tried 10B. Okay. Yeah, we just kind of have that one bug. Okay, is this running? No. PSAUX. Okay. HTOP. That looks good. Cat outputs 1 plot data. Yeah, there's no data yet. Your estimation, what is the likelihood that a jump call ends up with the PC at 0 is indicates user controllable? I mean, in this case, it's not jumping to null. So like here, it's jumping to this address, which is pretty random. Is it user controlled? Hard to say. The exec nulls. Those are likely the same bug. It's likely some heap corruption or a use after free that's causing us to jump to the wrong thing. It's really hard to say. It varies so much. I'd say typically like 10% chance. Pretty low, to be honest. Okay. Still not fucking running. Are they dead? They died. The fuck? Kill all of them. Do that. Make dir. Spawn them all up. Run this in a loop. Is it blocking trying to write to standard out? Probably not with the dev nulls. Oh, yes. I accidentally didn't have that one set. My bad. My bad. Thank you. I was trying to dev null it, and then I fucked it up. So, yeah, it was very likely actually blocking on that. Good catch. Okay. Basically, right now, they're running all the inputs through in the initial pass and all that shit. And then we'll see if it actually scales with cores. Given the amount of red here, I would hazard to say it's not going to scale with cores. But we'll see. It's trying stuff. It just gets worse and worse. Oh! It must have found a big input. Oh, is one of the inputs too big? Let's just see what happens when we run it in normal mode. Something about it is not happy. I hate this initial dry run shit. I think there's a way to turn it off, right? Like dry run environment variable or some shit. No instrumentation output. I built it with AFL. I built it with AFL's, no new output. Oh, I see. Yeah, I think instrumentation is working. It's just not. So, yeah, AFL is definitely. Basically, a lot of people push this like model of only use inputs if they're unique and dedupe your input database and your input corpus. Such a fucking stupid idea. That just assumes that one binary that hits the same code is the same as every other binary, and that's typically not even close to true. They're slightly different on states, they're slightly different on their behaviors, they're slightly different on their relation to other inputs. I think it's really fucking dangerous. And Window's too small. I think it's very dangerous to make those assumptions. Okay, why is this? Why would it be dying? See what error it's getting the benchmark strip? Yeah. Well, it's chugging. I love how the fuzz cases per second is such a small window that it jumps from like fucking 70 to 1,000 to 70 to 1,000, so you have no idea how fast it's actually running. Ooh, it found a hang. Nice. There we go. That's a good one. Yeah, so what's the fucking strat here? How do I have this go to the screen? Can I just not set it? If I do none, I think none. Standard out is none. Is sub process dev null. If thread ID is 0, standard out is none. Okay, and then we'll just say standard out is standard out, and standard error is standard out. I think that'll work. Yep, looks good. Can I stop the dry run? Is there a way? Let me see if I can find that. That would make this so much better. Okay. There's gotta be a way. The fuck is it? And okay, here we go. Perfect. No built-in. Quiet. Ooh, fancy. No fork serve. Exit when done. No skip crashes. Ooh, keeps the calibration stage. Okay. Okay. All right. Is this gonna do anything? Calibrate fast? Fast calibration? No. That results in a timeout. I see. Did I? Okay. Who cares? Who cares if it's a slow case? It's a case. Come on. AFL is so scared of large input files. Hey. Oh, I'm running multiple cores, am I not? I am. There we go. So now we can see the perf. Okay. Sweet. We'll just set this higher, and then let's see if we can use all 96 cores. Let's see. AFL should be able to find these bugs. I'm glad it does the dry run on all cores. That's really nice. God forbid it communicates something over threads. Or over some IPC mechanism. I don't think it's going to scale. I think the perf's going to go down with 96 cores. I think it's going to hurt performance. But maybe I'll be surprised. Maybe AFL will be much faster than anything I could ever imagine. Yep. It's climbing. Plot data. Oops, cat this. I don't know what those averages are. Execs per second. Is that cycles done? No. Cur path. Pending total. Well, we're getting 35,000 a second. Not bad. I don't know. Oh, you know what? This is definitely not a moving average. Yeah, this is not the performance I'm actually getting. Because this is not an actual average. This is like the past couple runs. Because it'll dip down to 7, and then it'll kind of erase that number from history. Yeah, that's kind of annoying. What the fuck is execs per sec? What does that even mean? EPS. Plot update. Average exec. If there's a dramatic jump in speed, reset the indicator more quickly. So you mean lie? Just like if you see a big perf spike, just report the spike perf? The fuck is that? That's some shit. Average exec. Total execs. I would hazard total execs. It's going to be a global, right? Yep, it's global. Total exec VE calls. Okay, so here's what we're going to do. Start time. Start time. Okay. That's in millis. Okay. Get cur time. Get Unix time in millis. Sweet. So, we can make our own stats now. Update. Maybe. Update plot file. Okay, perfect. So then, here, we will get the, double uptime is equal to minus start time. So... and then divide this by 1,000 to get the seconds. And then we'll just put this at the end. Percent 10.4 F. And this is uptime. And then we'll make a cases is equal to %10.4f, or 10 LLU. So uptime will be uptime. And then cases. What was it? Total execs. Okay. And then total execs divided by uptime. And this would be fuzz cases per second, 10.4f. Make. This benchmark parsing stuff's probably gonna fail now, but that, no big problem. I want the name in line. It's easier to split and parse. Outputs 130. Oh, it's not running yet. Don't I remove outputs in this? Okay. Oh, I'm in the wrong folder. Yeah, look at its reported fuzz cases a second, and look at its actual fuzz cases a second. I guess this number's climbing because this includes the time where it was doing bootstrapping stuff. Okay, maybe it's... well, there it just went down. Yeah, if it's going down, it's not a factor of the first cases. Yeah. So if you actually look at this delta, and we calculate it the way that we calculate, this minus, let's say this one, divided by this minus this, 362 a second, and it's saying it's getting 500 a second because it's literally just picking like the most recent spike in performance. Fucking ridiculous. It's insane to me. Like, how do people not fucking care? Like, look at this. It says it's getting 502. And if you take the cases and you divide it by the fuzz cases per second, these are the numbers you get. Jesus. I hate shit like this, man. I hate it. I hate it. Splits. All right, fine. We'll do this. This isn't too hard to parse. Okay. Okay, so then we'll have iters a second is -1. -2 is cases. And -3 is uptime. Okay. Iters per second, -1. So split, -1, -2, -3. And then we should be able to... I mean, now we just have a new iters per second. But we can do total iters is 0. Int total iters plus equals cases. Total iters 10. And then we can do uptime is equal to... Yeah, we can add all their fuzz cases per second. Honestly, we can take total iters, and we can do our uptime, where we can do start is time.time. And elapsed is time.time minus start time. And then we can just have total per second. This will just be float total iters divided by elapsed. So it'll literally just be that. And then this will be 12.4 elapsed. Okay. That deletes outputs. Spinning up all the cores. Numbers, what do they mean? Alright, we'll know soon here. Hopefully I did that math right. I think I did, and hopefully I'm parsing things right. Pretty sure I did. So now we'll get to see the actual fuzz cases per second. Not the made-up fuzz cases a second. Kind of excited. Kind of surprised they didn't decide to report the number of cases in the stats lines. Kind of weird to me. Okay, I think it's almost there. There it is. Okay. Oh, our thing broke, didn't it? I think our thing panicked somehow. Wiggle every time, boop. Start time. Yeah, it's start. Here we go. Okay. Boom, bringing everything up. Now, we see the uptime, we see threads, we see iters. Okay, what is going on with that uptime? Oh, I need to say F. Here we go. Okay, all the threads are up. I start the counter. This is uptime. Iters is 0. Fuzz cases per second is very much so 0. I don't know why I have that many sig figs on fuzz cases a second. That's kind of ridiculous. I have no idea. Okay. The question is, can we outperform AFL? Oh, I should have crashes in there too. I think there's a total crashes line. I should parse that out. Oh, there we go. Now we're running. Okay, it looks pretty fast. I'm seeing like 40,000 a second, something like that. It's a respectable number. Yeah, it looks like about 40,000 a second. Honestly, pretty good. Pretty good. I'm impressed. I'm impressed. Obs jump is actually a much bigger target than I thought it was. And here's what I'll do. We're gonna do start is equal to 0. Then we're gonna say if start is 0 and total iters is greater than 0, start is time.time. We're gonna start the timer when we get the first fuzz case. We're gonna just go right up to the end. We're gonna be really friendly. Okay. We added some shit. -3, -4, -5, -6. So -6 is crashes. Okay. Total crashes. And this is total unique crashes. And this will probably be wrong because it's gonna, it's probably going to end up reporting them in multiple different programs, but who cares? Crashes is equal to total crashes. And hangs is total hangs 10. I can do multi-line like that, I'm pretty sure. Total hangs. Total hangs is 0. Total hangs plus equals hangs. Hangs is at 5. Can't believe I have to write my own tool such that I can see the cumulative performance of AFL. It's kind of ridiculous. The fuck is that uptime? Oh, it's subtracting from start time, which is a lie. It'll reset to 0 in a minute here. The uptime's a lie, because I have it set to 0. That's just the Unix time, basically. And then it will drop to 0 the second the first iteration comes by. It's a bit of a hack. I'm not too worried about it. You're such a big fan of AFL, you write your tooling for it. Yeah. See, there we go. Uptime reset. Fuzz case is a second. Now we're giving it a really nice, favorable number. What? How the fuck? What? How is iters divided by uptime? Oh, it must like bulk report a bunch of things at the start. Okay, so then I don't want to give it that benefit of the doubt. Oh, here you can see unique hangs, so 192. Are you running? No, we're only running... Okay, so that's 2 unique hangs, because we're running 96 instances. Well, this is a generous number, because it's climbing downwards. It's actually more like 30,000. Yeah, it looks like about 36,000 a second, which is respectable. Probably the number of input files take a while to process. Yeah, I think that's what it is. So I should actually start the timer from the start. Okay. Yeah, I'm going to change that because that is just not true then. Time.time. And then I'll be right back. I'll just have this run for a minute. Where my crash is at? I thought AFL was the best fuzzer in the world. How has it not found a bug? I gave it the exact same corpus. Let's see, how long did it take for me to find a crash? It took me I found my first crash at 20,000, 30,000, 40,000, 50,000. Took me 50,000 fuzz cases to find the bug. How long is it going to take AFL? What's going on here? Is that 9 million iterations and it hasn't found a basic bug? I mean, that is fair. I am probably using a much more sophisticated mutation strategy compared to AFL because I mean, look, like, come on. Do you really expect AFL to beat this mutation strategy? No fucking way. It ain't got shit on this. Look at this. I even make sure, I go out of my way to make sure that I don't do a divide by 0. If I have a 0 byte input, I'm like, nope, I won't even corrupt it. I don't even bother changing the size. There's just no reason to. It's just flip random some random bytes. Come on, AFL. What you got? So, can I publish my work saying that I find bugs 100 times faster than AFL? Or I find infinitely more bugs than AFL? I ain't publishing shit. I'm just chilling. I'm chilling with my chat, my fan club, who I've made so many emotes and done so many things for you guys. Really going out of my way to be a good player here. No crashes still. It's running fuzz cases. It's trying. But, yeah, I don't know what's going on. So let's see. How many fuzz cases a second are we getting? A 1,000? We're getting 1,000 now? Oh, is that with, Is the AFL running during this? Oh, am I having cores fall off because I don't have timeouts? Okay. Well, AFL's doing AFL things. I really wish that log didn't scroll off the screen. Holy shit, it's off the screen, isn't it? Oh, there it is. Okay. Vim, AFL perf text, paste it here. Okay. And then wait, how quickly did I find those crashes? Let's try that again. Okay, instantly. Oh yeah, this isn't even the most recent data. It's pulling down all the crash files. I could turn that off, to be honest. And then, yeah, I think cores are getting stuck. I think that would make the most sense. So we might have to add timeouts. There's the plot. Okay. Okay, so we find a crash after about 1,000 fuzz cases. So what's taking AFL so long? All right, we got to fix these bottlenecks here. Let's go and instructions. Run insters, which we reset. So on a new case, we reset the run instructions. So thus the insters exec here should be indicative of, okay. How do I want to handle timeouts here? I could set insters exec to, yeah, here we go. To insters exec, and then here I just assign it. And then that way I update it going in and coming out. I update it again, but nothing's actually adding to it. And then down here, I can say program plus equals, and where do we want to do this? On branches or something? Jump and link. I guess on coverage event. I'll just put it in there. Coverage event. If state insters exec is greater than 1,000. Fuck it. Set exit reason timeout. And then re-entry, which we won't do. So we should be able to see timeouts here now. But basically, we'll check for a timeout whenever we do coverage, which is every branch. Yeah, so here we see, we're getting a lot of fuzz cases a second, right? We don't really have a cap on our performance. We can kind of do whatever we want to do. Let's go and see now. So, okay, that timeout clearly works. I actually thought I was going to have to plumb that more. Let's just set it to, I don't know, 100 million instructions, which is 1/10 of a second, roughly. Oops, can't do that. Okay. So we set our timeout to there. You're in C++, not Ross. I know. So Franny, thank you so much for gifting the sub to Browse, man. Hell yeah. Glad you're enjoying the content. Okay, just lifting that shit. I think 100 million instructions is a reasonable fuzz case termination. I feel like anything more than that's pretty aggro. So we'll see if this hurts our curves. So here we're coming online. Basically rejitting everything. I don't know. Maybe that's too aggressively short. Okay. And we have crashes. We already have crashes. Okay, nice. And now we're at 2 unique crashes. So, yeah, this is looking solid. This is looking real good. Sound like a smarter Sir Action Slacks. Holy fuck, I haven't heard that name in a long time. I used to watch like so much Dota 2. Like basically, if I was at my computer, I had fucking Dota 2 up. I was watching like Admiral Bulldog. I was watching like someone casting some pro games. I was surprisingly into Dota because I never really thought I was, but I definitely was. Okay, this is looking solid. I think we did hurt it a little bit with that timeout. I think it's a little aggressive. Okay. Let's see how we're doing on perf now. We're getting about 30,000 fuzz cases a second, which is what was AFL getting. Yeah, we're about the same speed as AFL. And we're emulating. Although it's about to drop. I think we found some expensive cases that were feeding back hard. Shame the timeout is part of the code. Yeah. I mean, I don't think it's hurting perf. Maybe it is. Yeah, I think some of these... I think these cases are just getting longer and longer on average. So the perf's kind of just dropping. That's kind of the nature of the beast when you're fuzzing. The deeper you get, the more time you get shit like this. That being said... Oops. Didn't want to run that. Let's make sure AFL is not running right now. I don't think it is. PSA. Yeah, we're good. 3 unique crashes. Pretty solid. All right, let's try. Let's give it a little bit more room to timeout, and let's drop corruption a little bit. And we'll see what that does. Who fucking knows? Oh, it's got to re-JIT because I changed the timeout. Shit. I could probably move that into a variable because I just make it, if I make it const, it'll get propagated cleanly enough. I don't need to actually pass it in as a constant. You just get him so you can set a timeout at runtime. Yeah, I mean that's pretty complex and sophisticated. That's a level of polish that I'm just uncomfortable with. Okay, how's this looking though? We don't know yet. Still not really running any cases. Okay, it's climbing. Ooh. Crashes looking about the same. Crashes at the same time. I expect that this will pull ahead over time. So initially it'll probably perform worse and then it will start performing better. It'll probably end up like right around this ballpark. I think it'll have a steeper slope that'll sustain for longer because the feedback will give it a little bit more time to dig its hooves in, you know? Picking up while I'm putting down. Okay. And looking good. Let's just go with this. I just want to reset it so I get the perf numbers now. About 11,000. We actually lose quite a bit of performance by having that that timeout so long. I mean, we're spending all our time in the VM, which is great. Less than 0.5% of our CPU time is spent resetting VMs. So we're pretty much... Okay, Yeah, it's just fine in fuzz cases that are really slow. Some really slow fuzz cases. But it might not matter that much. Okay. Yeah, look at that. See, this is going to climb much harder. That perf drop is brutal, though. I don't know. What if I did an aggressive timeout? What if I did, like, a much shorter timeout of, like, a million instructions, and I looked for, like, a really shallow crash? But I think there's a good chance that I'd miss stuff if I do that. So let's go and JIT cache star history C, and then we're gonna change this to state timeout. Okay, timeouts. Inserts exect const uint 64t timeouts. Okay. So then inserts exect timeouts. Let's try. Did we try 10 mil before? I think we did 100 mil. Let's try 10 mil, which is pretty aggressive. Let's see what this does for us. And now we can change the timeout here. And we won't have to recompile code. And I don't think that's really going to hurt perf to do that access. Would be a recommended technique for weighting inputs. So you could heavily weight coverage feedback derived inputs and underweight timeout prone inputs. I haven't had much success with weighting. I don't think it works that well, to be honest. I think biasing towards new coverage is a pretty large mistake that I think every single person does. AFL does it, right? AFL basically refuses to fuzz anything that doesn't have a prospect of new coverage that it's like fiending over because it's seen an untaken branch and it really wants to go down that path. AFL uses a queue system, and you'll see that I never use a queue system in my fuzzers. I think it's a really bad concept because it can easily bias towards whatever you're queuing for. Right? If you're issuing a queue and you're queuing up certain different types of corruption, well, great, now you're not going to find any bugs for a year because you ended up queuing up a bunch of corruptions that aren't the correct corruption. So I like doing just uniform, distributed, random over everything, and I like to solve my problems by my corpuses, my mutators, and my generators, not by biasing inputs. I think biasing weights of your mutators is good. I think feeding back information of which levels of corruption had the best results and yields, and then biasing your mutators and your generators for that. But I don't think biasing inputs themselves is typically very good. Obviously, you can find evidence of like, oh, I biased my mutations, or I biased my inputs, and I got much better results in this case. Yeah, because you overfit for your target. But I really haven't found a good generic way of weighting things against completely, like, all the different targets I've looked at. And thus, anything that I see that's weighting is probably pretty biased towards the specific target that it has. So let's get this going. We're going to have better perf now, of course. The question is, how are our results going to look? And it looks like it's making it a little bit harder to find crashes. We also might be getting unlucky on these crashes. But it looks like coverage is honestly pretty good here. And if we were to plot this in a time domain, right, if we were to plot these graphs with respect to time, in fact, I'm going to do coverage over case, and this is going to be X label will be time. I don't really care about crashes. Coverage over time. 1, 3. 1, 3. 1 to 3. 1 to 3. And this is an interesting graph sometimes. So, this is kind of the ground truth of fuzzer performance. This is the fuzz density, the ability for the fuzzer to generate good inputs at the potential expense of the time spent on those inputs. And then this is telling me my actual coverage over time. Now, if this line starts to fall off and intersect, then I'm probably better off having a larger timeout. So we can try that right now. So let's go and throw in, I think it's safe to say that right now it's pretty close to the green line. So let's go and set an aggressive timeout, or an aggressively long timeout. We'll set a billion timeout. And now we're going to see how this performs. And what are we getting? We immediately got more crashes. Oops. So look at this. We're overperforming on density, which makes sense, but we're underperforming when it comes to coverage over time. And in reality, coverage over time is what really matters. Coverage per case is a little bit more useful because you can basically, you can experiment with really complex fuzzers that you know you could optimize if you bothered to spend the time. But maybe you're hacking something together, you have a bunch of allocations, you're not ordering things efficiently, you're using shitty data structures, and you just want to see, does this theory make the fuzzer better? And you can look at this graph to tell you whether or not you made the fuzzer better. And then you can look at this graph to tell you whether or not you made your fuzzer more efficient. And, you know, if you can make something that's 10 times better, but it takes 100 times longer to execute, it's probably better to use a shittier fuzzer. And that's often the case. So here, it looks like we're doing really good, but we're actually doing quite poorly. I would say the shorter timeout had a better yield. Now, this might have a higher coverage over time, but ultimately, it's underperforming a pretty basic baseline here. So let's play around with a couple things. We're going to drop this down very low, and we're going to go to 1 million. And now we have everything in cache, so this shouldn't be too hard to run. We should immediately be getting results here. Okay, so now we might not get crashes, which is where things can get really strange. Is now we might start missing out on crashes because we're so focused on the front part of execution that we actually miss out on crashes. But let's see how it's looking for time. So in terms of coverage per case, we lost a little bit of density here, but we actually improved so minusculely that I don't even care on time. So I think so far it's safe to say that the 10 million timeout seems to outperform. So if you go back to the 10 million, I think this was ahead on both time and case basis. And here we go. Let's see what we got. So it's kind of at parity right now on time. We could also try changing mutation. It's a little bit denser, but actually not doing that much better on time. Interesting. Okay. Huh. Okay, let's run this again. We know that this line was basically identical to the green line. We'll run it again. We're going to see if we're getting slightly different results here. No, Nope, it looks about the same. So I think it's safe to say it's pretty stable. So now let's try another parameter. Let's try the amount of corruption as a parameter. So we're going to increase the amount of corruption, which for what we're used to typically will increase the amount of, it'll typically increase the coverage at the start, but then decrease the amount of coverage towards the end or over time. So let's see what we got. And here we go. It's overperforming on both. So it's safe to say that made the fuzzer better. I don't know why, but it did. It made it better in both domains. And when I see stuff like that... okay, what are all these fucking spam follows? Am I gonna have to turn this off? Yeah, I think I'm gonna have to turn off follows. Clearly, these are just fucking, like, spam accounts, I'm pretty sure. Because they all have the exact same pattern. So, let's just get rid of these. Okay, apparently Streamlabs isn't loading, but that's not a big deal, because I can just do this. Okay. Okay. So, yeah, fuck these spammers, man. I hate shit like this. Okay. So, we're trying to figure out if this made an improvement. And look at this! We've crossed over 8,000 for the first time ever. So, it's safe to say that I'm pretty sure the 128 byte corruption was an improvement. I don't fucking know why, but it was. So let's go to an extreme end. Let's go even more corruption. Let's go to 1024 bytes of corruption, which is ridiculous. But we'll see. Maybe it's better. Who fucking knows? Okay, it's kind of on par. So this seems to have hurt it again. And I can do, let's see. I really should make this update in real time, but there's not a good way to do it because I'm pulling down remote files. So that seems to have hurt us. Okay. Well, what about 64? Because I think 128 was good. And we're just trying to guess. Cockies, thank you so much for the tier 1 sub. Hope you're enjoying yourself here. Woo! Little Nessie going on there. Little Nessie action. Nessie on both. I mean, this looks pretty fucking good. We've got crashes coming in. Performance is looking solid. That's looking juicy. Yeah, look at that. Now, did we just get lucky with 2 bumps and it's really just the same as the green line? Because it does look like it has the same slope, and maybe we just got lucky twice. So, obviously, what we're doing right now is a really shitty fuzzer. Let's play around with a different flag. Let's try and find a bug in, instead of -G, -D to disassemble. So let's see if we can find a disassembly bug. This is going to hit a lot of different code. So we would probably want to actually fuzz kind of all these parameters at the same time. So yeah, we're just basically lifting a bunch of new stuff because it's completely new code, which is actually really neat. The cache actually kind of tells us what we have or haven't hit already. And it looks like this is just starting to warm up, which is good. Okay. Now, it doesn't look like there's that much code here, to be honest. Based on obviously, we're not comparing these graphs anymore. I'm just using this because it already exists. But honestly, it does not look like there's much promise in terms of surface for disassembly. Now, maybe that's because our timeout's too aggressively low. But we're just not really seeing any code coverage increase. This is actually going pretty much flat. Like, it's not looking good. G's got the juice, it seems. So, obviously there still could be bugs, right? We're just playing around with things. And this is what I typically do when I'm fuzzing. I do many 30-second fuzz runs until I feel like there's something worth running. I am very patient with my investment of CPU time. I don't just run a fuzzer for a fucking week and hope that it works. I try to figure out what makes it better or worse, because changing a couple parameters is typically the difference between a 10x and not having a 10x. Like, there are massive differences and improvements you can get by just being a little bit picky, with the things you're fuzzing. So this is an extraordinarily interesting curve. And here you can see this kind of spike that then goes logarithmic. I guess it's log on a log scale, so it's actually worse than that. And a little bump here, hitting some new code. Let's see what we got going here. Bink. Huh. So I'd love to see like a big increase in coverage here. That would be the sort of thing I'd love to see. I'd love to see a spike. But here's what we're going to do. We're going to go and get our best line on G. We're going to go to G mode, which is our best mode. We're going to set the timeout to 50 million, which I think is probably going to be slightly better. And we're going to set the corruption to 128, which seems to be a really friendly value. And I think this is going to be the best performing one we've seen so far. So we're going to have good perf, we're going to have good coverage, and we should have good depth because the cases go deep. And we got our crashes. We're up to 3 crashes, which is fantastic to see. Okay. And yeah, this is looking pretty good. In fact, on the time domain, it looks like it's struggling, so maybe we are better with a shorter timeout. We do have 3 crashes, which is nice. What's the one piece of software you never found an exploit in that you mentioned in your bio? It's a Wi-Fi chipset on a phone. I got smoked. I got absolutely roasted. So this line is looking really good. So it looks like right now we're on par to have like a 5x improvement. And are you guys feeling the same thing I'm feeling when I'm looking at these graphs? Are you noticing the changes? When we change these basic parameters, these basic timeouts and corruptions, we're seeing the changes in these lines. And that's what I'm looking for. And when I say, like, on Twitter and stuff, and some people question me when I say this, but when I say on Twitter, like, my goal is that my fuzzers can find every bug I know of in the target in a couple minutes, this is why. Because I spend all of my time, every time I find a new bug, I try to figure out, why the hell did I not find that sooner? Because typically there's no reason why you didn't. I'm doing 1 million fuzz cases in like a couple, like 60 seconds. I'm doing like 1 million fuzz cases a minute. Why on earth am I not finding all of the bugs right away? Like, the amount of cases, actually, I need to show you guys the inputs that I have, and there's There's a graph that I don't think I talked about it in like 2014 when I gave one of the first talks, or like 2015 when I gave one of my first talks, and it's fuzz cases per input, and we're gonna actually add that statistic because fuzz input.len inputs corpus.inputs.len. This is a number that I need to display, and we're gonna kill maybe crashes. I don't think I care enough about that. We're gonna say inputs 10, and we'll replace this stats.crashes with corpus.inputs.len, and then we're also gonna add another statistic to the file, and this is going to be the corpus.inputs.len, and this will display. Ooh, we're up to 4 unique crashes, which is nice to see. That's looking good. We're at 8,000. We're overperforming on here, but we're not getting a huge perf benefit, so I think I'm going to want to drop the timeout. We're just gonna switch this to maybe 5 million. Let's try and drop it down, because I think 10 million was the best one we tried. Okay, is the Fuzz Week accessible to watch? Not yet. I haven't uploaded it to YouTube yet, mainly because I've been streaming non-stop, so I haven't actually had time to really upload anything. But what we got going on here? This is looking good. I think this is looking good. We're probably losing some density here. Yeah, and then inputs. This is telling me how many unique inputs I've decided to save. How many things I viewed as relevant pieces of data about fuzz cases. So basically, anytime I get new coverage, I save a new input. It's seeded with the thousands of inputs I had at the start of execution. So we're going to add a set multiplot to 2. And then we're going to change this to y label as crashes, or coverage. This is going to be coverage over time. This is fuzz cases per input over time. And then this is fuzz cases per input. And I should have that in the 5th column. 1, 2, 3, 4, 5. So inputs is in the 5th column. So we'll compute fuzz cases is the 2nd column. Divide that by the 5th column. So fuzz cases per input. And then we'll change a 3 to a 2 over 5. Ah, son of a bitch. Oh, fuck off. Okay. So fuzz cases per input over time, and then we're gonna have this is going to be crashes, time and crashes, which I think is 4 if I'm not mistaken. Unique crashes is 1, 2, 3, 4. Yeah. So we'll change the 3 to a 4. And now we're going to see a little bit more data on our graphs here. There we go. So, now we can see right here, this fuzz cases per input over time. Now, what this fuzz cases per input is telling me, basically, inputs are the only thing you save, right? When you're fuzzing, if you find a crash or you find something, you save the input off that caused it. But, for example, I am doing a decent amount of fuzz cases a second. I'm doing 55,000 fuzz cases per second. And I'm doing 55,000 fuzz cases a second, but I've only saved 6,000 inputs. So that means For all of this compute time that I've done, all of these millions, this like 12 million cases, only 6,000 of them did I actually save any information of. That means, basically, if you take these cases and you subtract off this number, that is the amount of fuzz cases that I completely threw in the trash. I extracted no information. I extracted no crashes. I didn't build upon them. I didn't do shit. And in that situation, that's the number I care about. When this line starts to go exponential like this, it's pretty obvious that your fuzzer is stalled. Your fuzzer is no longer exploring interesting paths in a quick manner. You are discarding, right? You can view this as a ratio. I am discarding, for every one input I get any meaning out of, I throw away 2,000. And this is another reason why I don't give a fuck about 5, 10, 20, 50, 2x speedups in fuzzing. Because in almost any fuzzer, this is literally, the fuzzer has been running for about 2 or 3 minutes now, and for every one input I save, I throw away 2,500. That means there's a 2,500x speedup in the performance of this fuzzer if I like more densely generated fuzz cases, right? There is nothing stopping me from getting all of the coverage I have ever observed in the first 2,500 fuzz cases, or input fuzz cases, right? I could, in 6,734 inputs, with a perfect fuzzer that has perfect density, I could find all the bugs. And instead, I am throwing away, now I'm probably up to 3,000. Yeah, I'm almost at 3,000 fuzz cases that I'm discarding, right? So this is why I don't give a shit about when people find a 20% improvement in fuzzing, because you're already just throwing all your fuzz cases absolutely in the trash. Until you extract information out of this and do something meaningful with it, your fuzzer's just shit. So yeah, sometimes I'll turn on more coverage mechanisms. Like I'll start adding some state tracking stuff. And we can see if that helps us. So we could go add, what's the best place to add some extra coverage? Trying to think. Best way to sprinkle in a little bit of coverage sauce here. We are at 8,500 in code. Let's actually kill these crashes so that we can see what we're getting now. Secret to 21-hour programming is a 1-hour WoW break. Yeah, it hasn't been that much programming. We did like 2 hours of WoW in there. Okay. All right. So we have that one crash so far. What do we got? Obj dump, G, fuzz with emus, inputs, oops, crashes, read null. Okay, yep. This one doesn't quite do it. I'm guessing this is probably some memory exhaustion thing that I imposed because I have a smaller memory heap limit. I'm guessing it's just something's fucking not null checking something. Okay. Let's get those other couple crashes in here. Let's go. Let's go. Where are they at? Where are they at? So one of the things that I experimented with way back when in Fulkervisor was using a priority queue for crashes. And basically every time you found new coverage with an input, you increase the priority of that input. And you end up you just end up with a sorted list of which inputs are generating which coverage. And that actually had some really interesting results. It really hurt performance. Because it made me focus on really, really deep fuzz cases. But it did kind of help with some of the density of printing out some of the shitty inputs. But what I did to make it much better, like a massive improvement, was I had a 50% chance to ignore the bias entirely. So that way, even if it biased all the way to 100% for one of the inputs and just said use only this input, there's still a 50% chance that it's completely uniform. And that's a really good technique to use when you're trying to make your fuzzer much smarter, when you're trying to do something sophisticated and fancy, is to make sure you have a random chance of just making that shit dumb again. Because sometimes making that shit dumb again is why fuzzers work so well. So we're on, I think we last tried... Now let's try 69. Okay. Yeah, these null DRFs are very likely unchecked allocations. Okay. So I think what honestly is best for crashes is a large timeout. Let's try 50 mil. Let's give it a big ass timeout and let's see what we can get here for this data. And our fuzz cases per, if our fuzz cases per input is that high, then we have no reason to care about perf, right? I want my fuzzers to run as fast as they possibly can, but I also want to slow them down to the point that I'm actually doing something meaningful. And in this case, we slowed down the fuzzer by like a factor of 2, but we're actually getting some improvements off of it. We're getting crashes much sooner. We've found 3 crashes by 30 seconds, which is pretty sweet. And let's see what that third crash is. Let's see what it wants to show us here. This third crash, fourth crash now. Ooh, a 1-1, a free normal. This free should be a, that's basically an invalid free. Here's a right, here's a seg-v, there's a jump to null. So I think we're about to get spammed with crashes from this point on, because we're about to get some of those arbitrary executions. So I'm curious why this doesn't want to come out and play. Basically means we freed something potentially twice. Now, I don't know if... I can't imagine the file name matters. We haven't really tried it. I can't imagine it would matter, but let's try and make a copy. And we run this as test fn. Okay, so we're going to copy this to test fn. And then we'll run this against test fn. And maybe... No, okay, the name of the file didn't matter. I'm not too surprised. It does slightly change some of the rendering and output, but, We also aren't using our uninitialized memory tracking, which could potentially find some other corruption bugs. But there's just a lot of false positives when you have something like that running that can really kind of start hurting things. So let's see how this is going. We're doing good on both axes, looking great. So let's try and get a better corpus. Let's remove inputs. Let's copy user libs32 inputs to inputs. That's it. We'll just start with this. So now we've changed our corpus. We're hitting new stuff. Getting crashes fast. But let's see how much it hurts us. Looks like we're ahead. We're behind on time. It looks like some of these files are probably larger. So they're probably more expensive to fuzz, but they're denser. So we've increased the density, but we've really hurt the overall performance of our fuzzer. Okay. More complete fuzzing tool, you'd probably want to take these unique crashes from memory faults, run them in the emulator with logging of the malloc and free results. Yeah, I mean, I just dump a full trace typically. In a situation like that, I just dump a full trace and just see how that's going. Okay, so let's nuke the inputs and let's grab lib64. Actually, lib64 I think has almost nothing. Well, it has some stuff. Let's try it. Who fucking knows, right? Just trying things, seeing if they work. Typically, the bigger the corpus, the better the results. Yep, this hurt results. And this is pretty standard. It's just now we have a crash in there that's different potentially. Let's see what showed up today. Okay, we got those 3 crashes really fast. We'll remove those inputs and we'll grab just lib. Okay. So I assume this will perform a little bit better because it's just got more files in it, but who knows? And this is dog shit, right? This is the difference between corpuses. When you're writing a mutational based fuzzer, the corpus is really all that matters. So I think what we want to do is blast the, let's try user bin. Let's see what user bin is doing. Okay. Let's see what this does. This one looks really bad. This looks really bad. Yeah, look at this. It's, wow. Wow, this is trash. Okay. Unless it Nessies, but it's not going to. Yeah, it's just stuck. It's just not doing well. It's performing slowly. Okay. So that's a bad corpus. Huh. What's this? What are these doing here? These are fun. S390X. That sounds fun. I bet this is going to be ass. We're hitting some new stuff. Yeah, it's not doing great, but we are hitting new stuff. Do you need sleep? Nah, not yet. A couple weird Nessies along the way here. Kind of cool. And no crashes out of these. Although we're getting actually pretty good growth rate on coverage. It's kind of growing. But all right. Well, I think we've learned some decent things. I'm gonna go to bed because the sun's starting to come up and this is ridiculous. My sleep schedule is fixed for 1 day. All right. See y'all around. Hope you had fun.